Good morning, student. Today's topic is cyclic structure of glucose. In previous class, we have already learned the open chain structure of glucose having a 6 carbon atom. Here we will discuss about the D and L configuration. This D and this L. First of all, we will discuss D configuration. Suppose this is the open chain structure of glucose. If the OH group, this OH group, attached to carbon 5 is on left hand side, then it will form the L configuration. And if the OH group attach on the right hand side, then it will form D configuration. Here we write D, this D. The plus sign and negative sign shows the optical rotation, which is dextro and labio. Dextro means rotate the plane of polarized light towards right hand side. It means it shows plus sign. Labio means if the plane polarized light rotate towards left hand side, it will form negative sign. Here we'll take the example of glycerol aldehyde. This carbon having OH group which are present on right hand side, then it will form D configuration. And if the OH group attached on left hand side, it will form L configuration. Positive sign means rotate the plane of polarized light towards right. Negative means rotate the plane of polarized light towards left. Means dextro and labio form. Here we will discuss the cyclic structure of glucose. This is the open chain structure. At 5th carbon, OH group is present. This oxygen having a lone pair and it attack on the carbonyl carbon. When any alcohol react with the aldehyde, it will form a hemiacetal group. Hemiacetal form is formed. In this structure, there are two types of stereoisomers, alpha and beta, alpha D glucose and beta D glucose. This is hemiacetal form. The OH group present on right hand side at the first carbon atom, then it will form alpha D glucose. Other carbons remain same. If the OH group is present on left hand side, then beta D glucose is formed. Other carbons remain same. These two are the cyclic hemiacetal structure. How will you differentiate the alpha and beta D glucose structure? The structure which differ in configuration of OH group at carbon 1, then it will form alpha and beta. Only change in carbon number 1. Here the OH group is on right hand side and this OH group is on left hand side. These configuration is called as anomers. Next, except carbon number 1, if the configuration is changed on the other carbon atom, then it will form the epimer. Here we take the example of glucose and galactose. Glucose having this carbon number, fourth carbon number having OH group is on the right hand side, but in galactose this OH group is present on left hand side. So there is a small difference in the structure of glucose and galactose. Now the next topic is the reaction of glucose. Means some of the reaction of glucose cannot be explained by open chain structure, but it is explained by the cyclic chain structure. First of all, glucose don't give 2,4-DNP test. DNP means dinitrophenyl hydrogen test. This is the test of a carbonyl group, CO group, which are present in aldehyde or ketone. Next, it don't form addition product with NaHSO3. Third, it react with NH2OH, means hydroxyl amine, and it will form oxime. But glucose pentacetate does not react with this structure. Third, D plus glucose exists in two forms, alpha glucose and beta glucose, which are differ in configuration at carbon number 1. If the OH group present on right hand side, it will form alpha, and if the OH group present on left hand side at carbon number 1, then it will form beta glucose. Now the next, how will you write the Howarth structure of glucose? Means hemiacetal is formed. Then how will you write? Glucose is a 6-membered ring and having a oxygen atom. This structure is called as pyran. Means this is the same structure. Here the glucose is formed. This one. 1, 2, 3, 4, 5. 5 carbon, 1 oxygen in between them. So this is the same structure of pyran. Here the two structures are formed. Alpha D plus glucopyranose. This structure are formed. How will we write this structure? At first carbon, this is carbon number 1. It is formed by this one. At carbon number 1, left hand side H, OH, H, OH, OH, H, H, OH, H, CS2, OH. This is carbon number 1, this is 2, this is 3, this is 4, 5 and 6. Start right from here. Bulky groups are present from upper side. CH2OH group are present here. Here H are present. Next H, left hand side H. Here OH are present. OH, H are present. H, OH, H, OH. These are the alpha D plus glucopyranose structure. we can draw easily by the help of this cyclic structure. Next, beta D glucopyranose. How we can draw? First carbon, this one, second, third, fourth, fifth. OH group is present upside, this H, H, OH, OH, H, H, OH, or here CH2, OH or H. Thank you.